Hello, today we're gonna solve the last stone weight problem. Uh, to summarize, this problem asks us to do two actions. The first action is that we will choose the two heaviest stones as the weight x and y, and we will have two actions with x and y. If x equal y, both stones are destroyed, and if x is not equal with y, we will destroy the stone x, and the stone y would be equal to y minus x. So what we're gonna do now is that first of all we have to find the two heaviest stone in this problem. For example, if we have this, we will have the two heaviest one is x and y will be equal to 7 and 8, and then because x is not equal with y, so we will destroy x, and y would be equal to y minus x. So we can just keep y minus x right here. So to solve this problem, we can use priority queue or heap. We should use the max heap in this case because we want to have the two heaviest one. So keep going, and now we remove 7, remove 8, and we add y minus x, would mean 1 right here. And then after that we find new x and y. New x should be equal to 2 and new y should be equal to 4, and then we remove these two, and we will destroy x and y, and then we add y minus x. Here we will do the same right here. Yep. And finally we will have 2 1 1 1 right here. Sounds good. And we keep going. X should be equal to y should be equal 1. Yeah, actually we keep x less than y, less than or equal y right here, and then we destroy both of them and we add 2 minus 1 right there. Destroy both of them. So right now we will have 1 and 1 right here, and then we will add 1. Keep going, and we will have x equal 1, y equal 1. In this case we will destroy both of them. We will destroy x and y. So finally we will destroy these two, and we will have just one number right here. Yeah. So that's once we return the answer, which is the number 1 right here. So let's jump into the coding part. First of all, we have to have a priority right here. We can use priority in, and right here we will use max heap, and we can construct the max heap from this vector as well. We don't need to look through all of the element. We can just use the stone begin in stone, and C++ already supports us to do these things, so we don't need to look through all of the stone and add it to the heap. And we will have a loop right here. This is where our loop terminates, so we will terminate the loop when the size is less than 2 elements. So we will have twice the size of the heap greater or equal to. We will keep going, and first of all we will get the largest one, which is y. We have max heap right here at the top, and we pop the top element from max heap right here. After that we will do the same with x, and then if x equal y, we can just throw both of them, and we don't do nothing right here. Otherwise we can push max heap dot push y minus x right here, and here we can just put continue on nothing. That's fine as well. Yeah, right. So if we have max heap size less have greater than 0, which means that we remove all of the element and we have only one element left, so we will return this only element. Otherwise we just return 0 right here. Right. Yeah, we got the answer right here, and the time complexity would be O n log n, with n is the number of stones we have, and the space complexity would be O n, because we gonna use a max heap to store all of the stones, all of the numbers in this vector, so it should be O n right here. Yeah, that's all for this problem.